Hey guys, what's up? My name's AJ, and today I'm going to be taking you along while I build this Lola Preamp for a 500 series rack. I'm putting this together because a couple of my friends wanted to see how it was done, and I just wanted to show them that it's not as hard as it sounds. A basic knowledge of component sorting and a good soldering iron can get pretty much anybody through this build. So come along while we get this done. So this is how it came, packaged from Hairball Audio. You can kind of see everything's packaged in its own little box, so all the components that deals with that PCB or that section is packaged together. This is a good look at the main PCB. You can clearly see where all the resistors go. It's labeled very clearly. So some people use a pan vise. This is the little contraption I use. I mainly use it for soldering wires and stuff, but in this case I was able to wrap electrical tape around the jaws that helps protect the PCB from getting marred up from those sharp jaws. I can throw a link in the description. One of these, they're pretty cheap. I want to say around 20 bucks. Step 1. First thing we have to do is pop these op amp sockets in there. As you can see here, they come in bag F. One side is solid and the other side's open. That accepts the pin from the op amp. So as you can see here, all the open ends face up. That way you could seat that op amp down into it. These are one of the components that receive a ton of stress if you're constantly swapping out op amps to experiment with different tones and stuff. So as you can see here, what I'll do is I'll make one pass and I'll solder all the top sections, and then I'll flip it over and make sure the bottom has a good solder mount on it as well, just to create the best bond possible if you're pulling and pushing on that section there. And a good tip for soldering is to heat up one side of the component you're trying to solder down and touch the solder to the other side. That way the heat transfers through it and you get a good bond both to the component itself and the pad. If you do touch the solder directly to the iron tip, what could happen potentially is you create a cold solder joint, and these joints break really easily. They're brittle, and also since the two materials were at different temperatures when they bonded, they separate very easily with a little amount of stress. So just try to stay away from doing that and make sure you heat through the component. Here I'm just showing you the underside. I know the view isn't the best with this GoPro, but I switched to a different camera later so you can see some of the solder joints a little better and stuff. So on to resistors. There's a couple of different ways to sort these resistors. Online, Hairball Audio provides some sheets to pre-sort before you start the build. The way I like to do it is just one by one. That way I know I'm not missing one, I didn't put one in the wrong spot. I'm checking right before I place it into the PCB. So how I test them is swap this setting to the ohm symbol. This is the same symbol you see on the back of your guitar cabs and stuff. It deals with resistance, so it's all the same. Then I also set it to the auto setting. That way if you have a big variance in two different resistors, like kilo ohms to normal ohms or milliohms, it'll swap automatically without you actually having to turn the switch. So what you do is grab your resistor. You're going to put one lead on each leg of the resistor on either side, and it's going to show you a value. This one here looks like it's saying 10.1. So the variance, the 0.1, could be a lot of things. It could be the tolerance built into that resistor itself, or it could even be the resistance added from the leads that go to my multimeter. So it's safe to assume that that one is a 10 ohm resistor. So you put it in the location marked 10R in this build. The cool thing about resistors is they're not polarized, so you can't mix up which leg goes in which hole or anything like that. It could be placed in either direction and work the same. Although sometimes it is nice to put them all the same direction. That way when you come to troubleshooting, it's easy to calculate if you can't reach it with a DMM or something. On the underside of this, you can see how I bent the legs out. This just holds the resistor in place and makes it easy to solder them without them falling around and like losing their little location on the PCB. I'm going to speed up most of these parts of me soldering just because this would be a 3-hour video if we went at normal speed. So I've already showed you what a solder joint should look like and gave you some tips, so this is pretty straightforward. More resistors. Keep doing the same thing, measuring the resistors on both legs, populating the board one by one. You could pre-sort if you want. This is just a fail-safe for myself. One big thing to note though is watch out for the letters after the value on your DMM. You could accidentally place a 10 ohm resistor in a 10K spot or something like that, so just pay really close attention while you're measuring and placing these in there. That was probably the biggest part of the build. Everything after that, you're not stuffing nearly as many components in the board at one time and soldering down. So once you're past this, you're actually pretty much past the hardest part. It's freaking diode time. So diodes only let signal or electricity flow in one direction. So they designate this by a little gray stripe on the diode itself. And then also on the PCB, there's going to be a designator on the silk screen showing you which side to place that gray stripe on. If you were to install one of these backwards, signal would probably just stop at that point. Because these diodes won't let signal flow the opposite direction, it's kind of like a brick wall for electricity. There are certain types of diodes that will allow like an overvoltage to pass through. Those are called Zener diodes, but there's only a couple used in this build and they're clearly designated. Moving on to the relays. These are marked just like the diodes are, with a line on one side and the same on the silk screen, indicating which direction you put these in. Once they're placed, these pins are very small. So what I do is after they're inserted in the holes, I'll take my fingernail and I'll bend two of the pins catty corner to each other to hold that in place so I could flip it over and solder them. In this build, all of these relays are the same. They do different things in their different circuits, like make sure certain buttons work and switches work, but as long as you place them the right direction, they all work. Alright, moving on to capacitors. There's a couple different ways to tell which leg is which on this. On this type of capacitor, you can see that there's a gray stripe with a minus symbol on it, indicating that's the negative leg. The other way is that the positive leg on these is usually longer. So here on this other capacitor, you can see the stripe with the negative symbol, and then also the longer leg indicating positive. These types of capacitors are not polarized, so like the resistors, you could place them in either direction. To tell the value on them, there's a code printed on them. They're so small they can only really fit 3 symbols or 3 letters on them, 3 numbers. So this one's 101, which means 1, 0 is the beginning of the value, and the 1 at the end is how many zeros you add after that. So in this case, it's 1, 10 by the power of 1, so 100 picofarads. Capacitors are measured in farads. Luckily, Hairball has made this easy for you, and it tells you, it kind of like breaks down the code inside the guide, so if you're reading along to that, it should be really easy to know where this goes. More populating and soldering. There's a lot of this, if you can't tell. Next, we're going to install this header ribbon cable connector. These ones are pretty easy. They only fit in the board one way because there are these plastic guide pins on the sides that don't let you place them the wrong direction, which is really nice. By the way, I was holding up the box to show you that they were actually in the meter PCB box rather than the main PCB. Remember, you don't have to solder the plastic legs. I've seen people just melt the crap out of those things. Next is the gray hill switch. This has some really small parts, so you want to be really careful when opening this bag. I'll show you here once I get the switch out. So as you can see here, I don't know if you can see it. Yeah, there's this little pin, very easy to lose, and they don't give you an extra if you drop it or something. So here I'm removing the nut and the washer from the switch, and I'm placing that pin. If you hold the switch in this direction, it's going to be that 12 o'clock hole. Make sure you grab it. If you're not good with your fingers, grab it with a pair of needle nose pliers or something, because once you drop it, I don't know what you're going to do. Maybe use a lead from one of the resistors you clipped off, but those leads aren't very strong, so I don't know how well that would hold up, and I'm not even sure it would fit in the hole, to be honest. Once you're able to actually get that thing in that hole, you want to push it down so it's flush. Here I use my snips to press it down. And then you peel the sticker off and you place it over the top so that pin can't go anywhere. It's locked in there. And what this actually does is it prevents the preamp gain knob from being turned past 0. Some people might like that, but there's no need, because there's going to be this empty space in the taper of the gain instead of just, starting at step 1. So the alignment of these knobs and buttons through that front faceplate is crucial. You solder everything down, you won't be able to fit it through this faceplate. So here, just from doing this build before, I know that this needs to not sit nose down on the board. It has to be pretty much parallel to the board. So I'm trying to use this baggie at first to kind of be a riser. It didn't work out too well. So what I ended up doing is grabbing a tab off of this cardboard box, one of the component boxes, and just placing it underneath the switch or knob. That way it stays in place, and once this all comes together, it fits through the holes just fine. I know I'm probably going to be asked why I did this with the board facing that direction, and it's because I'm only doing one pin to hold it in place, so then I can swap it in. But whenever anything's placement dependent, when you're trying to align something to a hole, or align two components so they touch correctly, at first you just want to tack one leg down or something like that, just so it holds it in place. That way you can switch the position of the PCB to a more comfortable one, and then go ahead and solder the rest. Another good tip with these Greyhill switches, they seem like they're really robust and strong, but you don't want to blast them with heat for too long. I've read stories of people holding the gun to them or the iron to them for too long, and it melts the insides or oxidates the metal components on the inside. What that makes for is a really sticky, hard to turn knob, and that's not what you want with these Lolas. Next is the output attenuator pot. This one's pretty straightforward as well, just like the last one, but this one had some really bent pins. Must have got damaged during shipping or something, so I'm trying to straighten them out, being very delicate not to overbend them, because you bend them too far and they will break. They're very weak metal. And then you place this little riser. That's what's cool about this one. This spacer will put it exactly where it needs to be on that PCB if you mount it flush, to where it fits through the faceplate and the L bracket perfectly. I wish they would have made a spacer for all these other spots, or all these other components that do not just fit. Like I said, these switches can be rather delicate if you hold heat to them for too long, so try to make your moves quick, get enough solder on there to make a good connection, and move along. You don't want to just keep blasting these things with heat. Quick tip while trimming these small pins is to hold your finger over them so they don't fly and hit you in the eye.
Now we've got two working controls. The guide does talk about checking your L bracket to make sure it's got that guide pin hole. If it does not have that guide pin hole, you have to chop off that little guide pin. I just want to make sure the alignment's kind of all matching up so far. Very good. As you can see, the guide pin slips right there through that hole, and everything's actually lined up so far.
Moving on to the DI jack. This is the one that you cannot solder flush to the board and have it fit through those holes. The last time I did it, I wasn't reading the guide as thoroughly as I should have been, but I soldered it flush, and then when it came time to get it through the faceplate and that bracket, it didn't come close to matching up, so I had to spend time unsoldering and resoldering and stuff until I got it right. If you pay attention to the guide, read it thoroughly first before you build, then you shouldn't have this problem. This is where it sits flush. In order to get it to work with the rest of this stack, I have to build up some things first. So I'm going to take the standoffs out of the hardware box, a couple of the countersunk screws, and leave these standoffs kind of loose because you're going to need that wiggle room to finagle this together the first time. So once I get these installed here, it's going to look something like that, loose. I'm going to pop this together. Now you can see the DI, since this isn't soldered down, the DI will actually poke through, but what I don't like about it is that the back is lower than the front. I want it to be straight, so when I plug something in straight from the front, it's not putting extra stress on that. So what I'm going to do here is solder one leg from the top side just to tack it down like I showed you before. Now I'm going to put it in my little clamp and go ahead and solder it down. Moving pretty quickly here. But as you can see, there's going to be a gap between the PCB and that DI connector. It's not huge, but it's enough to create an alignment issue with everything stacked up, all the tolerances put together and stuff. I was able to get it straight, so it's not going to put extra stress on it when I plug it in either. Next, this is the input transformer. When you open this thing up, these leads on here are just crazy long. You're going to have to trim these down to size to make it work. But to mount it, I just grab a couple of these panhead screws, no washes or anything. It just goes right through the PCB and into these threaded holes. You want to be careful not to over tighten screws on anything plastic, honestly. The chances of it cracking are very high. So now we're left with these really long wires, and they only need to reach down to this PCB. So what I'm going to do is I'm going to trim these, measure out how long they need to be to reach to the PCB, and then give it a little bit extra just in case there's a mishap, or I get snip happy and end up going all the way through the wires instead of just stripping them or something like that. So I'll catch back up with you once I'm at that point. Just be careful not to trim them too short. Here you see we've got them trimmed. Next I'm going to go ahead and strip them back about 1/4 of an inch each. You don't need to be any longer than that.
Labeled really well so you know exactly which color goes where. There's two greens. They both go into this ground. It doesn't matter which green goes into which ground hole. They're actually connected. The pads are actually touching, so it doesn't matter. They're going to get connected. And I'm going to go ahead and throw this on a time lapse and get this part done.
Sorry guys, I had to swap cameras. My battery died on the GoPro, and I probably should have been using this the whole time. Anyways, I mounted this output transformer, and we're going to go through the same process. As you can see in the back, the input transformer wires have been routed nicely. They're not laying over anything. learning how to mod and fix tube amplifiers, I realized that wire routing is very important and keeping noise down and interference and stuff like that. So we're going to repeat the process, snip these wires down to size, strip them back, pop them in the holes with their colors, silkscreen on it, and solder it down. And at this point, ladies and gentlemen, you should have a basically working Lola. All you have to do is pop in those op amps, which I forgot to do when I tested mine and I started freaking out, but pop those in, and this is a fully functional preamp. The only thing left to be built is the meter bridge, that little LED board that sits to the side showing you your level, and some of the cosmetic stuff like the bracket and the faceplate knobs and stuff like that. But this is basically the Lola, everything that the audio passes through anyways. So this is a complete preamp, but we all want to see those LEDs jump when signal passes through it, so I'm going to get on to building those. Moving on to bag B for the meter PCB. This has the IC chips and the diodes. Luckily all these diodes are the same. These are the Zener diodes that I told you about earlier in this video. The design is, if there's like a threshold, if the voltage is over a certain threshold, it will allow signal to pass the other direction and go back upstream. I'm not sure what the purpose is in this circuit, but that's kind of what we're doing here. These were also, like the other diodes, designated by a stripe on one side, and then the silk screen also has a stripe on it, so you know which direction to go in. With these smaller PCBs, the big issue is everything's packed so tight on there, it's hard to find a place to stick the soldering iron in. So a lot of times we'll solder a couple things down, cut the pins, and then resolder the rest. Next are these IC chips. There's a little dot on them, and on this bigger one there's actually an indentation, kind of like a cut out of the end of it right there. That tells you which direction these needs to sit in. So I populated that off camera because that was really hard to do, and these pins are so short you're not going to have to trim them later, but if you watch me closely, I do all but that one row of the big IC chip, because those pads are connected to another hole that a kind of like a pass-through connector gets soldered into. And these are so tight that if you accidentally put a little too much solder on, it's going to cover up those holes, and you'll have to spend time sucking that solder out or using a wick. And my thought is that I just leave them unsoldered until I put that other component in it and just solder them both at the same time. I left this section real time just so you know exactly how long I'm spending on these pins. These ICs can be a little bit more delicate than just resistors and stuff, so I try to move fast and not hold the heat down. This part's sped up. More resistors. You guys have seen this part, so I'm going to skip ahead a little bit. Quick tip when you're doing the resistors for this LED meter PCB. A lot of the writing and the silk screening on there is so tiny, and the tolerances are just open enough where the pads can kind of overlap some of the writing and stuff like that. So in those instances where you're having a hard time seeing the values and stuff, that's when these come in handy. They're on the site. I just found that 1.4K. I couldn't read the 1.4K, but I was able to read the R112, so that's how I knew it went there. Just a tip. Have that sitting around for this section of it because it does get a little tough to read sometimes. A good soldering station is huge. I remember doing my first couple DIY projects, like a Radio Shack soldering iron, and the thing would just keep getting hotter and hotter the longer you left it on. So it'd start out really good, and then sometimes you know, touch a lead only for a fraction of a second, and the pads would start lifting and like melting off. So I had to do a bunch of jumpers and stuff using the parts of leads that I had cut off, and it was a mess. But ever since I got a temperature controlled soldering station, I haven't had those issues. That can be kind of pricey. I actually got this one for free from my last job. Power cable was damaged by one of the techs laying the soldering iron down on its own power cable. I soldered it back together, but in a medical environment, once a tool is modded, they cannot be used for production devices. So they threw it out, and I got it. Still works perfectly fine for my needs. Been kind of clearing my area after each step because it's easy to get a resistor mixed up with a bunch of leads that you've already cut and stuff, and it's just nice to keep a kind of clean workstation. Cool. So far, this is what we have. Nice clean connections. Not too much solder buildup. Working on really tight boards like this, it's important that you don't use too much solder because it's really easy to create a solder bridge. Some of these pins are so close together that you could create a short very easily by using too much solder. So try to refrain from going ham with that solder. Next step. These are going to be the capacitors for the meter. I don't think you guys need to sit and watch me go through this part again. It's the same thing. You guys know how to tell which is the positive and negative leads now, so I'll catch back up with you once this part's done. Next, we're going to throw the little toggle switch in there. Obviously, it can only go one direction, so can't really mess this part up as well. Alright, now is when we connect LEDs to your meter PCB. Drops in there like that. Remember, those leads that we left in there from that IC earlier are still undone, so we're going to have to grab those while we're at it. Now we just put everything together, and this should go pretty quick because there's not a whole lot left. Zoom this out a little bit. This through, line up all of our screws
with the holes. That one, that one, that one, and that one. Go ahead and tighten those up. Perfect. Let's grab the faceplate.
And there you have it. You've got a full preamp. Let's go test it out. Get this popped in here. Perfect. Nice. Test, test, test. Microphone's working. Check. That's good. Let's plug a guitar in. There we go. PCI is working. Let's check a mic that takes phantom power. Check. It's working. So there you guys go. I hope you learned a little bit about putting DIY gear together, a little bit about components and stuff and what they do. And I hope you have fun building your first DIY piece of equipment. Thanks, guys.